Welcome to this session of the ELI conference. My colleagues and I at the National Artificial Intelligence Institute for Adult Learning and Online Education are happy to spend an hour giving you an overview of what our institute is doing. And of course, in an hour, it's very difficult to cover something that's a 5-year, $20 million initiative. So really what we'll be providing you with is a menu. And we hope that you will use the menu after the talk to contact us if there are things that we're doing that you're interested in, and also to take a look at the website, which covers things that we aren't able to cover in the talk. So each of us is going to talk for about 13 minutes. First Scott, then Vrinda, who I hope will come, then Ashok, and then finally myself. Will include our professional introductions in the 13 minutes, so we'll each introduce ourselves. And we'll hope to have some time for questions at the end. So without further ado, Scott, please tell us about your part of the menu and what we're doing with large language models.
Yeah, thanks so much for that introduction, Chris. My name is Scott Crossley. I'm a professor of special education at the Peabody College at Vanderbilt University. And we've been working a lot on large language models and specifically developing large language models for intelligent textbooks. Next, Chris.
I guess not.
So we're developing an intelligent text framework that we call ITEL, which is Intelligent Text for Enhanced Lifelong Learning. The important part about this is that it's a framework, which means it's not domain specific. It means we can generate almost any text we want into an intelligent textbook. And the hope is that we can do so by ingesting it automatically through like an R Markdown or other types of formats and automatically produce a textbook that you can see on the left that is more intelligent. What we developed so far is a nice content management system that allows for the automatic generation of intelligent texts. And the intelligence that we have and the interactivity that we have so far based on large language models are short constructed responses and feedback, and summarization, scoring, and feedback. And we're really focused on developing a user cognitive presence. Next. In terms of increasing cognitive presence, we do this simply by allowing users to practice specific skills. And the specific skills that we're focused on at this point are basically knowledge skills and retrieving and storing information. And this practice is instrumented through large language models. Next. The first type of kind of practice and feedback that we give users is through constructed responses. Think of constructed responses basically as short answers and questions that come from those questions. So we want to generate constructed responses because giving students questions and having them interact and answer questions usually can lead up to a half a standard deviation in learning. So it's an important goal to reach. And most previous work on automatic scoring of constructed responses have been domain specific. So we want to develop large language models that are not domain specific. So basically we can fit them within the ITEL framework to address a variety of different topics. Next. This is our constructed response pipeline. We have a pre-processing section that I'm going to talk about first, generating candidate answers, providing feedback to users through these large language models. So let's talk about the pre-processing next. And next. Pre-processing is relatively simple. What we want to do is we want to develop questions. And so what we do is we use large language models like ChatGPT and Vicuña to generate those questions. We don't want to just generate any types of questions. We generally want to generate inference questions, recall questions, and summarization questions. Recall questions and summarization questions tackle exactly what is covered in the text, while as inference asks users to make links between the text. What you see on the right-hand side is the ability for ChatGPT to correctly develop questions. And for the most part, ChatGPT always produces a good question. It just doesn't always generate the type of question we want. So it's very bad at generating inference questions. So almost all of the questions that we have to integrate so far are either recall or summarization. We also want to generate incorrect answers. So we have something to compare the correct answers to that the students produce. And we also want them to correct or generate correct answers so that we can compare incorrect and correct answers and provide feedback to learners. ChatGPT is very good at generating incorrect answers and correct answers. We tried to use open source large language models like Lacuna, which is the only one that we show here. Those open source models were less accurate. And for the most part, we had human raters go through and judge how accurate ChatGPT and these large language models were. And we found that they were generally quite proficient at it. Next. So now that we have the pre-processing, let's talk about the candidate answers from students. Next. And then next again. What we ask students to do is read through a part of a text, and then we blur out the next section of the text, as you can see at the bottom here. The users are then asked to answer questions to proceed. These are the answers that are automatically generated in the content management system. And this is all in alpha version right now. And you can see it basically says like ITEL's an alpha training. It gives a question, and then we ask the students to generate information. So what we really want them to do is get out of the practice of being passive readers, but more active readers. And then once they answer the question, we can proceed. If you want to check out a demo, we have that in the right-hand side. Next. And then let's talk about the large language models that inform these. Next. And then next again. So we did training on something called a multi-RC dataset. It's from about 450 sources. And these were all given to basically crowdsourced workers, so Mechanical Turk workers. And they were asked to generate questions and answers. And so they generated about 5,000 questions. And then they generated about 20,000 answers. And they were supposed to be like multiple choice reading comprehension. Some questions do have multiple correct answers. And in fact, about 44% of the answers were correct. And so we were going to use this as a training model. And the idea is when these large language models see a question, then they can look at the answers and they can say, like, is this a correct or an incorrect answer? We wanted to test how well large language models are at doing this. Next. So we used a reference model, and basically we provided the large language models with the target answers provided by the students. And then information from the source was distilled as a reference answer, and that was provided by ChatGPT. And those models always provide candidate answers and reference answers. And we asked the large language models, we basically said, hey, here's a candidate answer. Here is the reference answer. And they have no access to the context. We tried a couple of context models. They did not work as well as a reference model. And then within this system, correctness was determined by the similarity between the target answer and the reference answer. And we used two large language models on this. We used MPNet and BLERT. And let's see how well they did. Next. We reached accuracies of over 80%, especially for MPNet. BLERT is a little bit different. It's a distribution of scores. So we basically set a threshold of 0.7, and anything that was above a 0.7 was scored correct, and anything below was scored incorrect. But we were reaching relatively strong accuracy just using candidate answers and reference answers. So we decided to move forward with that. Next. And altogether, 84% of the items that we checked were scored correctly. And then about 11% of those items demonstrated disagreements between MPNet and BLERT. And so we're pretty comfortable in saying to our users, hey, you've answered this question. We're pretty sure it's correct or incorrect. And if the two models disagree, then we provide different type of feedback. So let's go next again, Chris. And then next again, because we're going to talk about feedback, and next one more time. So this is what our feedback models look like. Again, this is in alpha testing. If the student gets it wrong, it's marked in this red box. We have feedback for iterative redesign and retraining. We have these thumbs up and thumbs down, basically, that we can ask users to say, was this helpful or not? The users can also resubmit the question if they want to, or they can skip it. And if they get the question correct, we get this nice little green box saying it was correct. And this is the basic feedback mechanism behind it. But the idea is that we are now at a point with AI that we can generate constructed responses automatically. We can generate answers to those constructed responses, and we can then generate feedback to learners about whether their constructed response is correct or incorrect. And as we've seen in lots of previous studies, these types of constructed responses and interacting with these constructed responses really lead to learning through reading. And so we're at a point now where we can make a text much more interactive, much more intelligent, and hopefully lead to much greater learning gains. Next. I don't know if you heard, Chris. Perfect. The other thing that we do in ITEL is we do summary writing. This is just another approach to get students and users to actively present what they think the text is about and actively get them thinking about the text. And one way to do this is through summarization. Summarization has been shown over and over again to help students consolidate knowledge, reconstruct knowledge, store knowledge, and it's also been used oftentimes to assess reading comprehension. And so our summary writing interface looks a bit like this. After the students read a section of a text, they're asked to write a successful summary. As you can see, it's between 50 and 200 words long, written in English, because all of our textbooks right now are in English, is on topic and not plagiarized. And we have a lot of kind of NLP stuff on the back end that make sure that all of those kind of iterations are matched. We don't allow students to also paste either. So next, please. So on the back end of our summary scoring model was built on a long former, which is a pre-trained large language model from Allen AI. And we built it to predict human evaluations in 2 dimensions of competence. And basically what we needed on the back end was some type of corpus that was already pre-scored and pre-designed to provide summary feedback so that we could fine-tune these models. And we're in the possession of about 5,000 summaries from 100 different sources that have human ratings for them. And they basically have human ratings on 2 different things: content, which is main ideas and details and cohesion and voice, and then wording, paraphrasing language. So we developed 2 models to score content and wording so that we could provide feedback to learners and users about the strength of their summaries. Next, Chris. This was the large language model accuracy. You can see it's pretty good. The content model had an R score of 0.82. The wording model had an R score of 0.7, meaning for the most part, it explained about 80% of the content accuracy and about 70% of the wording accuracy. And this was based, again, on a long former model. Next. We want to do more than just provide learners with feedback on their content. We want to give them something that's actionable as well. So we've also used large language models to extract key phrases automatically from the content. And we don't, as with everything, we don't require that authors define key phrases. We let the machine learning models in the back end do it. But it also allows us to provide specific feedback to users. So if users don't pass content, we can say, hey, maybe you should consider some of these key phrases that you did not include before. And we took all of our key phrases from KeyBart. And we did find that key phrase overlap was relatively correlated with content scores, and that's the bottom right. Next, Chris. This is what our feedback mechanism looks like in ITEL. Users have the opportunity to write a summary. This summary in the bottom is written about Python, a programming language. And then we provide them with feedback on the wording. How well are they matching the content? Are they borrowing topics at all? How similar is the topic to the topic of the textbook, and which key phrases are missing? The key phrases are provided at the end of the first sentence where it says, try to include the following keywords: syntax, rule, web pages, and assembly language. Note that this Summary did not pass because its content was not strong enough, and we provide feedback as well. So these are a couple of the examples that we're working on AI-ALOE to make textbooks more interactive, more personalized, and just more intelligent so that we get students and users out of the traditional mindset of passively ingesting knowledge and get them into a more formal mindset of actively engaging with the textbook and learning through that textbook. Thanks, Chris.
Scott, thanks so much. And I hope that all of you who view this either live or in archived form will contact Scott and others at AI-ALOE if you have questions or ideas about how we're using large language models. So next, I'm going to ask our colleague Vrinda to talk about the architecture and the data structures that we're going to be using as we implement all of our tools. And Vrinda, please feel free to put your professional introduction in as part of your time, and just let me know when to advance the slides.
Sounds great, Chris. Thank you. So hello, everybody. My name is Vrinda Nandan. I'm a research scientist and product manager for AI-ALOE's A for L. And today I'll be describing to you our product and architecture. So let's go to the next slide, please. So let's start here. Why do we need A for L? At AI-ALOE, we are building an AI-powered learning environment, brimming with insights into adult learners and their experiences. So what I'm going to be discussing here isn't just about deploying an AI technology, but it's the design of a socio-technical system. And that's where A4L comes in, enabling AI cognitive assistant personalization through 3 key steps. The first one is collecting data from diverse sources. Second, analyzing this data. And finally, applying insights to tailor the learning experience. Next. So at the core of our data-centered approach, we have identified 3 pivotal levels of interaction. First is the micro level, where we fine-tune AI interactions to enhance the learning experience within a single instance. Moving up to the meso level, we carefully shape the learner's entire course experience. Here, A4L supports meso learning, molding the learner's experience within a course through data from AI agents and external data sources. And we'll talk more about these in the coming slides. And finally, we have the macro level. And at this level, we're orchestrating multi-year learning journeys that truly transform lives. Here, A4L enables longitudinal studies to measure learner proficiency. Next. So what is A4L? Let's dive into the architecture behind the AI-augmented adult learning, or A4L. So A4L is a dynamic and continuously evolving system currently under development. What sets it apart is its unique design, finely tuned for AI-powered learning analytics. And of course, we've seamlessly integrated data from diverse sources within AI-ALOE, enhancing the data's quality and then rendering it ready for analytics and visualization. At its core, if I were to summarize the 3 key components, you have a data pipeline, and this features the integrated ETL pipeline, which means extraction, transformation, and loading of the data. Second, we have the data store, and finally, the data model. Next. So now let's explore the data engine's conceptual architecture for data optimization and management. So as you can see here, the data engine efficiently handles data from various formats, including custom and caliper compliant data in both CSV and JSON formats. So all of the blocks in orange are potential sources for data. And users can opt for either automated data ingestion via the data upload API, or they can choose manual uploads for flexibility. Then the data in our data lake undergoes meticulous cleaning and further ETL or extract transform load transformations to ensure quality and consistency. Finally, the process data is conveniently stored in a central repository for easy retrieval. And of course, a lot of our use cases involve AI cognitive agents. So we wanted to enable access to this data through a simple yet robust data access REST API. And this is suitable for use cases such as personalization, analytics, and visualization. And of course, we also provide a data model that includes essential metadata, such as data dictionaries and schemas. So overall, now stepping back a little bit, this data engine serves as the backbone of A4L, facilitating both seamless data collection and on the other end, storage, which then allow us to do analytics and visualizations. And as you can note here, it is optimized for AI-specific tasks, excelling in both data preparation, model training, and evaluation processes. Next slide. Now let's talk about how A4L helps. A4L allows personalization, as I described before, based on performance in previous classes, and some of the data sources that we tap into span AI technology, such as AI-ML-based tutoring systems, online labs, and AI cognitive assistants. We also gather performance and demographics data from learning management systems, student information systems, and surveys. And as you can see here, I've categorized these into two buckets: AI technology data, where learners and AI technologies are interacting, and we collect all of that data. And also we have external data sources, like it says here, online discussion forums, LMS, EDM, SIS, and surveys that are tailored for the particular use case. So overall, this diverse data pool drives then the personalization of learning experiences, assuring that the learners receive tailored support. Next slide. Now let me give you two examples. The first example, of these are synthetic examples, more future-looking, is for Jill Watson. So here, A4L facilitates intricate learning analytics. In this example, we are using Jill Watson. That is our question answering agent that answers questions about course, textbooks, syllabus, and schedule. And as you saw, A4L already collects data on learner demographics, including age, gender, and location, as well as academic performance or learner performance metrics such as GPA. So when you combine this unique learner data, including both interactions with Jill Watson in terms of questions and answers, and then the comprehensive data set around demographics and performance data, that then allows us to derive meaningful correlations and helps us uncover new insights. So you might take the example, for instance, we can discern the types of questions posed by unique learner groups, right? Older learners versus younger learners, based on gender, etc. And even those questions that one learner group may have posed, but the other learner group failed to ask, and thereby support learners on their learning journeys. Next slide, please. Next, let's talk about another AI-based online learning environment. This is a lab called Vera, and this is a system where learners are involved in self-directed learning. And one example of how A4L can support this system is we can help Vera provide personalized feedback to learners, where the feedback is based on individual personality traits. So for instance, we may create learner surveys that ask questions that help us extract traits such as need for cognition. And this trait gauges one's inclination for challenging cognitive activities. And this data, the survey data, which is actually external to Vera, the online learning environment, can then be used within Vera to customize integrated coaches, where the coach may help a learner who seeks help versus may not help a learner as much if they are more inclined towards independent cognitive activities. And as you can see from this example, this is personalized now and based and customized to each learner's needs. So with those two examples, I hope you got a little bit of the sense for how all the data that we've enabled in our data store can help with personalization. Next, let's talk about, in the next slide, the comparison. Chris, can you go to the next slide, please? Yes, this one. Thank you. Some of the comparison between DoD's ADL, which is the Advanced Distributed Learning Initiative. I'm sure some of you are familiar with that. And so they have this architecture called the Total Learning Architecture. And I'm going to compare and contrast that with A4L to help you understand what's unique about A4L. So purpose, I think for A4L, the purpose is to focus on AI-powered learning analytics, whereas the TLA or Total Learning Architecture is a versatile open source framework for learning analytics and analysis. As far as flexibility, A4L is optimized for AI tasks, but ADL's TLA offers flexibility, adapting to various tools and systems. Data collection, both are dedicated to collecting, storing, and analyzing learning data, and A4L emphasizes on the AI-centric approach. Development stage, I think, is the key difference. Of course, TLA is providing this open source framework, and the arrow where I have A4L shows you that A4L is very early in its journey. They're at level 1, and the development stage will continue to evolve as we grow and meet more demands for AI in education. And TLA, of course, is an open source specification and very mature. Finally, for implementation, I think ADL's TLA has a very broad application, and A4L is better suited for AI-focused organizations that have such agents and need data in that correct format. Okay, next slide. So I know some of you are involved in DARE, or the Data for AI Research infrastructure stemming out of Australia. And these two, DARE and A4L, are very similar. Both emphasize the need for scalable infrastructure, prioritize the ability to work with data. We are not doing real-time data analytics yet, but that is in our roadmap. Both are evolving to meet the user requirements for data and analytics, and both are designed to optimize data management. So it was this is my guess, but maybe the potential difference here is that A4L's primary goal is to harmonize data from all the sources that I described to you, and really hones in on those cognitive AI agents and how we can personalize learning and aiding learners, teachers, and AI researchers with analytics and data visualization. Next slide, please. So now let me summarize some results for you. As you saw, we've engineered A4L's data engine, our flagship product, which serves as a versatile tool for AI ML agent personalization, data analytics, and visualization. We've enhanced the data workflows to support various data formats, like I mentioned Caliper before, which is standardized data, and we also deal with custom data in the platform. And overall, I think the higher data quality and ETL processes have really streamlined our workflow. Of course, we are committed to data governance and data lineage tracking, and doing our best to meticulously document all the details about the various data sets that we have already captured. Next, around data collection, we have collected many data sets now spanning from spring 22 to spring 23 last. Currently, we're in the process of collecting all the data for the summer term. And the data we've collected so far comes from TCSG and Georgia Tech, both college and university systems within Georgia. And we're 60% complete in our summer 2023 data collection. And last but not the least, we have developed a comprehensive data schema or dictionary based on data collected in cycles 1 to 4, or that spring to spring time frame I described earlier, and created a conceptual data model for all of our AI technologies, including actually a subset of our AI technologies, including Jill Watson, Sammy, and Vera, and we are expanding it to include all of the technologies currently associated with AI-ALOE. And then finally, I'll leave you with our next year's goals from the NSF. So NSF has provided us with some very clear vision and goals for year 3 of our 5-year roadmap. The first one is the goal to analyze adult learners' needs. Here we'll use A4L's data engine to extract insights and enhance job performance for adult learners, also in the professional settings. Next, personalized learning. We talked a lot about how we are personalizing learning and then expand that to include engagement, retention, and skill acquisition. Next is development for online learning. So here we are looking into improving cognitive presence, teacher presence, and learner social presence while assessing the correlations with learning outcomes, as we talked about in the Jill Watson example. Next is instructional approaches, how we can make that more innovative. And using this system, we can help teachers improve their instructional approach. Next is STEM learning and how we can improve that. So focusing on studying the underserved and underrepresented groups, because as you saw, we have tremendous amount of data about demographics and learner performance. So how do we make those correlations and impact their learning outcomes and access? Research with testable hypothesis. So we have a very comprehensive issue hypothesis tree in our organization, where our goal is to be able to create various issues and hypotheses, and all our hypotheses will be testable. And we're currently in the process of course, testing the hypotheses and also expanding our tree. And last, to demonstrate scalability, the conceptual architecture I showed you is currently in the prototype stage. We are conducting usability research, and we've built it with the purpose of scaling it over time. So all the components are there, and with our user research, we'll be ready to scale it. That's all, and I'll pass the floor now back to Chris and Ashok. Thank you.
So, Vrinda, thank you so much for that overview. And I'm now pleased to pass the baton to Ashok Goel, who is the Executive Director of AI-ALOE and the Principal Investigator for it.
Thank you very much, Chris. I'm going to begin by sharing just a little bit about AI-ALOE itself. So AI-ALOE is the National Institute for Adult Learning and Online Education. It was established in late 2021. So we are approaching the end of our second year. It's established by a $20 million 5-year grant through by NSF. And the goal here is very simple. AI, we live in the age of AI, and AI is disrupting many, many schools and displacing many, many workers. And the chances are that this trend will continue, at least in the foreseeable future. So what happens to all of these workers? Now, we think that AI can be part of the solution. It can be part of the solution by reskilling and upskilling workers who are already in the workforce. So that way, fewer workers have to lose jobs. And even if someone does lose a job, then they can do reskilling and upskilling and rejoin the workforce. So that is our goal. Our goal is to help reskill and upskill adult learners. So we are not talking about a typical 18 to 23-year-old college-going population, but instead we are talking about people who already acquired a skill and now are trying to reskill and upskill. And we'll take examples of that in a minute. So at the top level, our goal is how can we enhance the capacity and proficiency of adult online education? Now, online education comes in because we're talking to adult learners who might be in their 30s, 40s, 50s, 60s, maybe even the 70s. Many of them have jobs. Many of them have families. They cannot just leave their jobs and families and go to places of education. We must take education to them. So that's why online education. But when you take online education, then the quality of online education varies a lot. When it works, it can work very well. But some of the time it doesn't work very well. So the question is, how do we use AI to improve the capacity and proficiency? Now, the word proficiency here is important. We are talking about skill learning in preparation for future learning. So learning perhaps some set of skills in this class so that the learner can do better in the next class. Or proficiency of skill learning in preparation for workforce execution. So are we really helping the learners learn skills that will be useful in the workforce? Now, we have two hypotheses in AI-ALOE. Of course, you might say that there could be a third hypothesis and a fourth hypothesis, and it's entirely possible that some other team will come and explore hypothesis 3 and hypothesis 4. At AI-ALOE, we are exploring two hypotheses both based on very well-known theoretical constructs. The first has to do with personalization for adult learners. This is Benjamin Bloom's 2 sigma effect, which talks about one-to-one tutoring or one-to-one coaching teaching. The second hypothesis has to do with online education in particular. So about 25 years back, Garrison et al. Came up with this framework that they call cognitive inquiry framework, which says that something that happens in in-person education that doesn't quite happen in online education, that something is cognitive presence, teacher presence, teaching presence, and social presence. So cognitive presence is, for example, a kind of sustained conversation that you may have with the educational materials. So given such a big goal, and given the huge range, the huge variety among adult learners, where do we even begin? Now, there is no one technology which is going to solve the entire problem, because it's a very large problem. So what we are trying to do is to build a quartet, or sort of a, if you wish, a symphony of AI techniques and tools. And I'll talk about 4 here very briefly. In fact, I'll talk so briefly that I'll essentially give you the key ideas, and then I'll not get into any technical details. The first is Jill Watson, and Vrinda alluded to it briefly. Jill Watson is an example of conversational courseware, whether it's a textbook or a syllabus or these presentation slides, for example. Most, especially in online education, professors and teachers use presentation slides very often. Well, these days you can't talk to presentation slides of the kind that I'm using here, but you should be able to. And when we say talk to, we are not just talking about question answering, although that's a key component of it. We're really talking about extended, sustained conversations. So one question and answer, then another question, another answer, and this becomes a series of questions and answers until it becomes a conversation. This on the bracket I have shown TRL. This stands for Technology Readiness Level. So 8 is a pretty high level, which means it's ready to go. We have already used versions of Jill Watson for more than 10,000 students and more than 40 classes. We know it works. Ivy is in a similar way for videos. Online classes use videos, extensive use of videos, but these videos are not interactive. They encourage passive learning. In fact, they support only passive learning. How could we make these videos interactive? So a few years back, we built these interactive videos where after every 6 to 8 minutes, after every lesson, we spliced in a coach. The coach presented an exercise, and as the student did the exercise, the coach understood enough about the exercise that the coach could provide interactive feedback on the student. So that's the key idea about Ivy that has been running in one class, but now we want to generalize it and so that it runs in potentially in many more classes and other teachers can use it. SAMI. I should say that Ivy is a technology readiness level 2, which means that it's not quite yet ready to go for any class. SAMI is a technology readiness level 5, so it's somewhere in between. Learning is not just a cognitive process. Learning is a social process. Learning is an emotional process. How do we support social interaction between online learners? They imagine there are 500 students taking online class. They're geographically distributed. There's asynchronous learning going on. These 500 students don't know each other, and they never meet together. Well, that's not a very conducive atmosphere for many learners for effective learning. Could we think of AI as a social actor that, for example, helps facilitate social interaction among these learners? Finally, Vera and Vrinda alluded to this also a little bit, is an interactive modeling environment for systems thinking, and it now supports personalized learning. I'll share a little bit about how it supports personalized learning in a bit. And that also is roughly at technology readiness level 8. And I say that because we have used it in many, many classes. We have deployed it, and we have empirical data to suggest that it works. Okay, so let me begin by describing just a little bit about Jill Watson first. So the goal here is enhance cognitive engagement and teaching presence in online classrooms. And we are using AI assistant, and this AI assistant is called Jill Watson, that supports conversational courseware, any kind of courseware. And that led us to think in terms of Jill Watson. Now, over the years, we have used Jill Watson in many, many different contexts. Initially, it started with IBM's Watson platform, hence the name Jill Watson. Then it used BERT, and now it uses ChatGPT because ChatGPT is, from a conversational perspective, more powerful than, let's say, IBM Watson was 10 years back. So here is an example. We can use a generative AI to do that, and there are some advantages doing that. You enhance accuracy and coverage. It can extend to any natural language document, but there are also disadvantages using ChatGPT. ChatGPT can have hallucinations. It can have biases. It can have fallacies. And that's really troublesome. No one wants to introduce a large language model like ChatGPT that hallucinates. So the question for us became, this is the solution at the bottom. Can we combine ChatGPT and Jill Watson in such a way that ChatGPT answers the back end, Jill Watson answers the front end, and Jill Watson reduces ChatGPT's biases and hallucinations, yet exploiting ChatGPT's power to build this conversational courseware? And so that's what we exactly did. This is a sort of a very, very high level architecture, and I'll not go into the details here. But in the pre-processing part, Jill Watson looks at the documents in the courseware, and it tries to identify which part of the courseware might have an answer to the question that a student may have asked. Then it sends it to ChatGPT. ChatGPT finds the answer. And then in the post-processing phase, Jill Watson uses a technique called textual entailment to verify that the answer is a plausible answer given the initial document, initial courseware. We have introduced this Jill Watson backed by ChatGPT in our class on Technical College System of Georgia, the Wiregrass College, in a class on English composition and rhetoric. I should mention very briefly about Technical College System of Georgia. This is a 22 two-year colleges, and by the state law of Georgia, these colleges have to admit any student who applies to them. So these are not very selective colleges. Many of these students, they don't have high school diplomas. The median age is 26, and the age distribution goes all the way from 18 to 60 or so. So that these are sort of adult learners. And we have deployed it in that particular class this particular semester with about 120 students. And I can share some preliminary results. Jill Watson is doing just fine. It is able to answer questions. But interestingly enough, in this particular class, we are finding that students tend to ask a lot many questions about the class syllabus than they ask about textbooks or presentation slides. So that has been an interesting theoretical issue for us. It's not just a question of answering questions or engaging in extended conversations, although that's part of it. Another question is, what kind of questions do students ask? And the tools we are building are beginning to provide insight into it. Now, here is an example where we can show Jill Watson suppresses hallucinations from ChatGPT. So on the left side is all the questions students ask, we send them to ChatGPT by itself. We also send it to Jill Watson plus ChatGPT to see what the difference in the response will be. So because this is a course on English composition and rhetoric, a student may ask, what is drafting, in the sense of drafting an essay? And ChatGPT gives an answer about military drafting. Whereas Jill Watson gives the right answer about drafting in the context of that particular class. So there's an example how it is suppressing hallucinations. And there are several examples like that. We also introduced Jill Watson, backed by ChatGPT, in a class on online Masters of Science in Computer Science. And again, I want to share 30 seconds about this particular program. It's I'm told, the world's largest online Masters of Science in Computer Science program, and is specifically mentioned for reskilling and upskilling. Many of these students coming into this do not have an undergraduate degree in computer science. They might be coming from architecture or philosophy or English or things of that kind. So, and they are trying to change their career trajectory. The median ages are in the mid-30s, and students vary in the age from mid-20s to the late 60s. So again, we are collecting data here, trying to decide what the teacher presence is, what the cognitive presence is. And again, a preliminary result, it doesn't even show up here. So you are the first ones to hear about this preliminary result. Again, Jill Watson is doing very well. It can suppress hallucinations and biases. Here, students are asking a lot many more questions about the textbooks and presentation slides and video transcripts. So video transcript is also part of the conversational courseware. All right, that much about Jill Watson. I hope that gives you some idea about what Jill Watson does, what its power is, and also what its limitations are. I'll talk very briefly about interactive videos. I have only one slide on interactive videos. We call it the Ivy project, and like I mentioned, almost all online programs have huge amounts of video, hours and hours of video, and students sometimes get very tired of them, just watching video after video after video. So several years back, we took a video in a particular class, and after every concept was taught, after every skill was taught, we introduced an exercise. But the important thing about this exercise, this is learning by example. This is learning by doing. This is active learning going on. And as the student tried to go through this exercise, and I'm not going to go through the details of the exercise, as the student makes mistakes, the coach behind this exercise gives an explanation and says, well, this is a mistake, and here is why it is an explanation, until the student gets it right. So this is also, there is a degree of competency learning built in here. Now, Ivy, however, when we built it in fact, 2014, several years back, that was not generalizable and scalable. So now we are building an infrastructure and a methodology that we hope will be generalizable, scalable, and perhaps other teachers might be able to use it for their own online classes. I'll give a similar one slide presentation on SAMI. Learning is a social and emotional process in addition to a cognitive process. And for many learners, learning on their own is a huge challenge. They need a support structure. They need to be part of a community, of a learning community where they feel at home. But how do we do that? So SAMI is an AI social actor, which looks at initially the introductory posts that people are posting on the online discussion forum, and it has just started looking at other posts that students post during the course of a class, and builds connections between them. So it might say, well, you are in Sydney, but it so happens that you have children who are in elementary school. So I understand some of the problems that you have with time management. And you are in Chicago, and it so happens that your children are also going to elementary school. Maybe the two of you should get together. Let me introduce you. And maybe there are issues of time management that you can discuss with each other. We have found, we have introduced SAMI in many, many classes, at least 30, 40 classes, and we have found that many students, not all students, many students find this very useful. Okay, I hope that gave you some idea about SAMI. I'm going to move on to Vera because this is a quartet and I want to cover the entire symphony. So systems thinking is a major skill. We are surrounded by natural, social, technological systems all around us. And not only systems thinking is a skill, modeling is a skill, just like design is a skill, modeling is a skill. Um, Now, I expect that many members of this audience are very, very familiar with modeling and are very, very good at it, but not everyone is good at it. Can we build interactive environments, excuse me, which can help with modeling as a skill? Sorry about that. So we built this interactive virtual laboratory, as Vrinda was calling it, called VERA, for Virtual Experimental Research Assistant. Right now, it works in the space of ecology, but we are trying to build a more general version of it that can work in any agent-based domain. So you can build interactively conceptual models of some ecological phenomena. So, for example, if temperature of the water rises by 1 degree, what will happen to the sea turtles in East Georgia? Now, in Australia, the sea turtles are dying because the temperatures are rising in some of the coral reefs around there. Will that same thing happen to Georgia also? So a learner these are self-directed learners. So one characteristic of adult learners is that adult learning, a lot of adult learning is self-directed. So these are self-directed learners who build models, and then Vera provides a way of doing automatic agent-based simulation so that the learners can evaluate their models and if needed, revise them. Vera also provides access to Encyclopedia of Life, which was built by Smithsonian Institution, is the world's largest library of biodiversity. And in turn now, Encyclopedia of Life provides access to Vera. So now the Vera is accessible globally by potentially anyone through Smithsonian's Encyclopedia of Life website. So here is what we do. As learners distributed globally are using the Vera laboratory to do whatever models they want to build. And we don't know who the learners are. We don't know anything about their demographics. We don't know anything about the learning goals. We don't know anything about the learning assessments or learning outcomes because these are purely self-directed learners. It's not in a pedagogical context. But we look at their modeling behaviors, we analyze them using a series of machine learning methods. I'll not go through all the machine learning methods, but one of the machine learning methods is hierarchical clustering. And then using hierarchical clustering, we found that the self-directed learners typically fall into 3 groups. There is one group of learners who do construct models, but they don't evaluate it. And another group of, so these are what we call them model constructor. We call them constructors. Another group which sort of builds the simulations and just observes the results of the simulation, but they don't construct their own model. Now, what we want to do models, evaluating them, revising the models, and so on, the sort of full exploration. Now you can see how personalization will come into play. At runtime, we will do the analysis of the detailed learning trajectory here, the modeling trajectory, and then we will be able to provide nudging input to the students. So we also do Markov chain analysis so that we understand the sequence patterns in great detail for each learner. And then we use coaches, automated coaches that provide personalized help based on the modeling trajectory of each learner in order to nudge that learner into a more productive learning behavior. We have introduced this tool in pedagogical context also. I just want to share something interesting that happened that when we introduced it in a technical college system of Georgia, the teachers there used it in a surprising way, in a way in which we had not envisioned and we had not suggested to them. They found that the students liked Vera as an interactive model enough that they started using Vera for summative assessment. In fact, their entire final examination was based on Vera. And interestingly enough, a large number of students use Vera fairly well enough. These are students who are learning to be natural resource management. And natural resource management in these days of environmental crisis is becoming an occupational skill. They are actually people who are trained for years in order to become, let's say, park rangers. All right. I mentioned that these are sort of, this is a quartet. All of these are connected with each other. In Ivy, for example, the interactive video, we are trying to see whether we can build Jill Watson as a guide on this side. Similarly, in the Vera environment, and access to Jill Watson is available as a guide to the Vera's user guides. So these are all intended to work together rather than work in necessarily in isolation. And this is how we are trying to see whether we can support online education for adult learners. And I want to end just by acknowledging the really smart people that I'm happy to work with in my lab. It's they who do most of the work. Thank you very much.
So Ashok, thank you. We are almost out of time, but I do want to present more of the menu and hope that you will look at the slide deck carefully when it's made available, as well as the video, and use it as a menu for further exploration. So I work with some very talented colleagues on the learning and education part of AI-ALOE. It's not all artificial intelligence experts, even though it is a national AI institute. We bring expertise in adult learning and online education. And so just skimming through some of these slides, it's a very complex area with many, many different kinds of learners in many, many different venues. And online learning is a way of reaching out across that range of venues to make a difference. The adult learning research group here looks at the unique characteristics of adult learners who are of different ages, which shapes their learning. There are different amounts of work experience and life experience, which shapes their learning. They have more commitments than earlier stage learners in terms of family and other kinds of life situations. There's also a group within Georgia Tech's Center for Continuing Education that is about 21st century universities. And that group has a lot of ideas and insights about how universities can morph and change to become more flexible, to become more centered on lifelong learning, and to offer different kinds of certifications and degrees. So there are some colleagues not here today that really bring a lot to the table, and a lot of publications that relate both to online learners and also to adult learners. I want to highlight, though, other work that's taking place outside of the Institute. This is an article that came to me just yesterday on all of the ways in which AI might be conceptualized as helping the community of inquiry model, which is what, as mentioned earlier, is a model that we find with social presence, cognitive presence, and teaching presence to be a powerful way of thinking about online learning. And so beyond just the work happening within the Institute, we really want to be a nexus, a point where people who are also working in this area can come together either in partnership or simply in loose collaboration to share ideas together and to build on each other's work so that we can accomplish some exciting goals together. So I'm going to stop at this point. I want to thank George and the Eli community for making this opportunity available to us. And 2 years into the Institute, we're very excited about the opportunities that it provides, and hope to be interacting with you over the next few years as we all explore together on this journey with AI. So George, back to you.
Thanks very much, Chris. What a fantastic session, just to see the ways that practically AI projects and tools are being deployed. Seeing the critical nature of the tech infrastructure, I think that's something that's often overlooked. The old tech and old data architectures aren't going to be what we need in this new environment. And also excellent to see the solid grounding in learning sciences and existing sort of ed tech research. I think one of the things you see with the joys of any new technology is we sweep everything we know away, and then later on we have to rediscover it. So I think you did an exemplary job, including those dynamics, practical tools, practical impacts, and yet a visionary architecture for ongoing development. So what an outstanding session. Thank you very much. For those of you that are here, as you're aware, we're still happily going on. The next room opens. I think Grace probably has it open now. So if you want to join in, we've got hours of joy ahead of you. So thanks again to the whole team at AI-ALOE, and I really appreciate this outstanding talk.